Hello everyone. Today this is my 8th lecture and today we shall discuss about the electric line of forces and their characteristics. What are electric line of forces? Electric line of forces actually the visualization of electric field. Electric line of forces are the visualization of electric field. First of all, we shall discuss about the definition of electric line of forces and electric line of force. What are electric line of forces? Consider there is an electric field, and in electric field if we put a charge particle or pointed charge particle with charge q, then this charge particle will experience electrostatic force, and due to this electrostatic force this charge particle starts motion with the following a certain path. That certain path is called electric line of force. Again I am repeating, when a charge particle is placed in an electric field, then a charge particle experiences electrostatic force, and due to this force the charge particle starts its motion with the following a certain path. That path is called electric line of forces. So electric line of forces are the imaginary path. The imaginary path, followed by unit positive test charged particle placed in an electric field. Electric line of force or electric field line. The imaginary path followed by unit positive test charge particle placed in an electric field. This is called electric line of forces. It is also defined just as the curve on which at a certain point the tangential line drawn gives the direction of electric field at that point. About it we shall discuss in the characteristics, or you can define the electric line of forces also in the form of it. So now we shall discuss about the characteristics of electric line of forces. Characteristics of electric line of forces. Characteristics of electric line of forces. There are few characteristics. The first one is electric line of forces are always perpendicular to the conducting surface or surface of a charged conductor. Again I am repeating, electric line of forces are perpendicular to the surface of a charged conductor. The second character is greater is the density of electric line of forces, greater will be electric field intensity. Again I am repeating, if in a certain region density of electric line of forces is greater, then electric field intensity will also be greater, and if the density is smaller, then electric field at that region will also be smaller. Means if at a certain region, if electric line of forces are close to one another, then the density will be greater and electric field intensity will also be greater. And if electric line of forces are farther from one another at a certain region, then the density of electric field intensity will also be smaller, and it will show the lesser magnitude of electric field intensity at that region. First one, electric line of forces are perpendicular to the surface of a charged conductor. Second one, greater is the density of electric line of forces, greater will be electric field intensity, and vice versa. The third characteristics of electric line of forces is that electric line of forces are the curves on which a tangential drawn at a certain point gives the direction of electric field intensity at that region. And the last one, electric line of forces never cross each other. Electric line of forces never cross each other. If they do so, means we consider that two electric line of forces crosses each other, then at their point of intersection on this electric line of forces, the direction will be this, and according to this electric line of forces, the tangential line will be this. According to this, the electric field intensity will be along this arrow, and according to this electric line of forces, the electric field intensity will be along this arrow. And it means at a certain point there are two separate electric line of forces at a single point, and we know that electric field intensity or direction of electric field shows the direction of motion of charged particle at that point. That means a single charged particle cannot move along two different directions, so electric line of forces never cross each other, and electric line of forces never has two separate directions at a single point at a place. So these are the few characteristics of electric line of forces. The first one is electric line of forces are perpendicular to the surface of charged conductor. This is the first characteristic. The second characteristic is greater is the density of electric line of forces at a certain region greater will be electric field intensity at that region, or vice versa. Next character of electric line of forces is a curve on which a tangential drawn at a single point gives the direction of electric field index. Electric field intensity. Next character. Electric line of forces moves from positive charge to negative charge. They never moves from negative to positive charges. They always move from positive charge to negative charge. Electric line of forces, electric line of forces move from positive to negative charge. And the last and fifth characteristics, electric line of forces, electric line of forces never cross each other, never cross each other. If they do so at their point of intersection, at their point of intersection to separate tangential lines can be drawn. That shows two separate directions of electric field at a single point, which is never possible. Which is never possible. This is also an important question in CBSE board, that electric line of forces never cross each other. Why? The answer is, if they do so at their point of intersection, two separate lines can be drawn, and that shows the two separate directions of electric field at a single point, which is never possible. So these are the few characteristics. Again I am repeating, electric line of forces are perpendicular to the surface of charged conductor. The second one, greater is the density of electric line of forces at a certain region, greater will be electric field intensity at that region, or vice versa. And a curve on which a tangential drawn at a single point gives the direction of electric field intensity at that point. And electric line of forces always move from positive to negative charge, and electric line of forces never cross each other. If they do so at their point of intersection, two separate tangential lines can be drawn that shows the two separate directions of electric field at a single point, of which is never possible.